All right, let's get started with this review. First problem. 54% of students entering four-year colleges receive a degree within 6 years. Is this percent different from or for, and mathematicians can't, they have bad grammar. Is it different from for students who play intramural sports? 158 of the 268 students who played intramural sports received a degree within 6 years. What can be concluded at the level of significance of alpha equals 0.05? So the first part of the problem, you need to determine what kind of test you need to use for this particular problem. And what kind of test do you need to use? We have one population, and we're given a proportion. I can get my pen to work. Okay. And immediately when I see that I'm given a proportion and it's one population, this is a one proportion z-test, correct? So the first thing you're going to choose from the drop down is what? It's a big old long wordy answer. This is a z-test for a population proportion. Okay, so that's the first thing that you need to do. That's part A. What's part B? Well, part B, I need to create the null and alternative hypothesis. And what's the key word here? Different? Is it different? So what's this going to be? This is going to be not equal to. So the alternative hypothesis is not equal to because they're asking me, is it different or not? All right, so what's the null? Is the null equal then? Okay, and then what are they equal to? Well, this is a proportion, so we're going to pick P. P is equal to what? 54%. So we're comparing the sample that we took to what we think the population is, and that's 0.54, correct? So there is our null and alternative hypotheses. All right, so what kind of test are we going to run? We're going to run a one proportion z test, correct? And so our test statistic is going to be a z-score. All right, so let's go run that test. All right, so I'm going to go over to my calculator. I'm going to go stat tests, and I'm going to find my one proportion z-test. Is that number 5? And then I'm going to put in the information that they give me. So what I'm testing against is the 54%. So P sub naught, P sub 0 is 0.54. And then what did my survey come up with? That 158 of the 268 students who played intramural sports received a degree within 6 years. So is X 158? And is N 268? And I'm testing the alternative is not equal to, correct? Bless you. All right, so let's calculate. So my z-score, and they're telling me to round that to three decimal places, is 1.628 to 3 decimal places. And my p-value, by the way, on my particular test that I'm doing, just to warn you, they're all failed to reject the null hypothesis, which doesn't mean that your test is going to be failed failed to reject the null hypothesis. I kept thinking maybe one of these problems would be reject the null hypothesis. None of them are. So when you do your review for your test, be aware of that. So my p-value to 4 decimal places is 0.1036. So let's go write that down. So my z-test statistic was 1.628. My p-value was 0.1036. They do tell me to round that to 4 decimal places. So my p-value is what? It's greater than alpha, correct? So we're going to choose that it is greater than alpha from the drop-down. So what's that mean? If the p-value is greater than alpha, do you fail to reject? So from this drop-down, we fail to reject. Okay, so we can't conclude based on this data that it's different. All right, so looking at the final conclusion, the data suggests the population proportion is not significantly, and that is true. That's what we're looking at. This data is not significant. It's not significant enough for us to assume that there is a difference from the 54%. So I'm going to reject anything that says it's significant. Well, that one says not significantly. So now I need to determine from those two, which is it? The data suggests the population proportion is not, and it's the different right here. That's what it is. Because that is what I'm testing. I'm testing to see if the proportion is different from 54%, which is what our assumption is. So it is going to be the first one, correct? Because the other one says is equal to. No. That's not what we're testing. We're testing to see if it's different. Okay, let's look at the next choice. Interpret the p-value. So what did we get for a p-value? For a p-value, we got 0.1036, which is what, 10.36%? Because they give the answers in percentages. And p hat, or p prime, is 158 over 268. That is our test proportion, our sample proportion, and that's 59%. Okay, well, it's not going to be this one. That's too easy. And it's not going to be this one. And the way I know that is because they put the word sample in there. So what am I interested? I'm only interested in answers that contain population proportion. And I think we need to scroll up a little bit because there is one more answer. It's not going to be that one. So it is going to be that one. And the key word is population. So if the population proportion of students who played intramural sports who received a degree within 6 years is 54%, and if another 268 students who played intramural sports were surveyed, there would be a 10.36% chance, that is the p-value, that either more than 59% of the 268 students, which I misspelled students in the test, surveyed received a degree within 6 years, or fewer than 49%. And to be totally honest with you, the 49% is kind of obscure thing for you to find. By the way, you can find it, but it's kind of obscure. But that is the correct answer. Okay, let's interpret the level of significance. What was our level of significance? Was that 0.05, which is 5%. And we've got two answers that contain the population proportion. Which one is it? It's going to be this one. How do I know it's that one? Because of the word different. Is that what we tested in the alternative hypothesis? Is the proportion different than 54%? And it's not this one because they used the word equal. No, that's not what we tested. What we tested was, is it different? All right, problem 2. And I'm sorry for the blank pages. That's just the way when I print this from my Open Math, it prints. All right. The recidivism rate for convicted sex offenders is 12%. A warden suspects that this percent is different. So what's your alternative hypothesis? Not equal to. If the sex offender is also a drug addict. Of the 314 convicted sex offenders who were also drug addicts, 47 of them became repeat offenders. What can be concluded at the alpha equals 0.01 level of significance? So part A, again, from the drop down, you choose what test you're going to run. This is a population proportion, correct? And there's only one population. We're only looking at this particular group of sex offenders who are also drug addicts. So this is going to be, again, what? A z-test for a population proportion. That is what that drop down, we're going to choose from that drop down. And again, how do I know this is a proportion? They don't give me any means. Do you see anywhere in there that the mean is, the average is? They give me a percentage, correct? The recidivism rate. So I know it's a proportion. Okay, so what are we going to do? So our null and alternative hypotheses are going to be P. The null is going to be equal. The alternative is going to be not equal to, because that's what we're testing. Is it different? And what is it? We're checking against the 12%. Okay, so we're going to again do a 1 prop z-test, a 1 proportion z-test. Okay, so let's go run that. Okay, stat test number 5. And we're testing against what? That 12%? And what does our samples give us? 47 out of 314?
Can you press stat? Did you do second stat or you just press stat?
Just stat. And then arrow to the right to tests.
Oh, yeah, number 5.
And number 5. And we're testing again, not equal to, just different, correct? All right, are we ready? So what's your Z score? 1.619. Now, I did put in 1.6185 and it took it. It tells you to round it off to 3 places though. And they tell you to round the p-value off to 4 places. So that's 0.1055. Okay, let's go write that down. Or type it in, as the case may be. So the test statistic is a z-score. So pick z from the drop down, and it's 1.619 to 3 decimal places, and the p-value is 0.1055 to 4 places. So again, the p-value is greater than alpha, so choose that from the drop down in part E. So again, since the p-value is greater than alpha, I am going to fail to reject. I probably should have chosen a different review, but by the time I got, 15 problems in, I went, oh. I probably should have done a refresh on those. All right, so I failed to reject because the null, the p-value is greater than alpha. If the p is high, the null must fly. All right, so what are we going to conclude? Okay, it's not significant, correct? Since the p-value is bigger than the alpha, the preset alpha, the data that we got is not significant. Okay, so then we got to decide which of these two are true. Is it this one? Because is that what we're testing? That it's different? Interpret the p-value. Again, what was our p-value? Our p-value was 0.1055, which is 10.55%. That one's pretty obvious. I don't really have to do anything there. Not to give secrets away, but if it says population and none of the other ones do, that is the answer. All right, what are we going to interpret? Alpha. What was our level of significance? Was it 0.01, which is 1%? Population. Okay, so we got two with population. We got this one and we got this one. The other two we can ignore. And this one says equal, so it's not that one, correct? We are testing, is it, if it's different, so it is that one. If the population proportion of convicted sex offender drug addicts who became repeat offenders is 12%, and if another 314 convicted sex offender drug addicts are observed, then there would be a 1% chance that we would end up falsely concluding that the proportion of all convicted sex offender drug addicts who become repeat offenders is different than 12%. And the reason it works out to be that one also is because what is alpha? Alpha is the probability of making a type 1 error. And what's a type 1 error? A type 1 error is rejecting the null when it's true. And when you reject the null, you accept, and I'll put that in quotations, you accept the alternative. So if you repeat this survey, there is a 1% chance you're going to reject the null hypothesis. And if you reject the null hypothesis, you accept the alternative. So you're accepting the fact that the repeat offenders is different than 12%. Don't you like the last one? There's a 1% chance that lizard people, aka reptilians, are running the world. Okay, question 3. Nice easy one. Whew. If n is 170 and p hat is 0.9, construct a 99% confidence interval. In order to use technology, you need to compute the number of successes, and they give you the formula. So what are the number of successes? N, which is 170, times p hat, which is 0.9. And my handy dandy calculator says that is 153. Okay, so we're going to be conducting, or we're going to be creating a confidence interval for a population proportion. Okay, so what are we going to use? We're going to be using a 1 proportion z interval. So we're going to be creating an interval for a population proportion. Okay, so let's go to our calculators. And again, we're going to go stat arrow to the right to tests. Do you see a one proportion Z interval? Is it A? It is A. And once you figure out which test you're going to run, it's a matter of plugging in the numbers, isn't it? So what was our X? We calculated that to be 153, is that correct? And our N was 170. And we're wanting what? A 99% confidence interval. So our confidence level will be 0.99. And then calculate. And they give you the lower limit, that's the first number, comma, that's the upper limit. And that's how they write an interval in mathematics. To write an interval from a lower number to an upper number, you put the two numbers separated by commas inside of parentheses. So the lower limit is what? 0.84073. The upper limit's 0.95927. So let's go write or type that in. And they'd say 3 decimal places. So to 3 decimal places, this is 0.841. And to 3 decimal places, this is what, 0.959? Kind of nice to have a breather, because then you get to the next problem. And again, I apologize for all the blank spaces, but that's the way this thing prints. Is the average time to complete an obstacle course different when a patch is placed over the right eye than when a patch is placed over the left eye? 8 randomly selected volunteers first completed an obstacle course with a patch over one eye, and then completed an equally difficult obstacle course with a patch over the other eye. The completion times are shown below. Left means the patch was placed over the left eye, and right means the patch was placed over the right eye. Assume a normal distribution. What can be concluded at the alpha equals 0.10 level of significance? So what kind of test are you going to be using? Would help to see the drop down, but there are 2 sets of data here. So you've got a choice. 2 independent populations or what? 2 dependent? Which is it? Why is it dependent? Because you're doing the same thing, but one's over one eye and one's over the other eye. It's the same person, correct? Okay, so if I look at the drop down, you got this big old long drop down. The answer is paired t-test for the difference between 2 dependent means. So since that's the kind of test you're running a test on the difference between 2 population means. I need to find the differences. You can do this however you want to do it. You can put both of those sets of data in a list and then go over to L3 and find the difference. Or you can calculate them. And I'm going to do right minus left. Since I'm only going to be looking at are they different? So my alternative hypothesis is that the mean of the differences isn't equal to 0. So are they different? Are the two means different? They either are or they aren't equal to 0. So you're looking at is left minus right. If they're the same, then the difference is 0. Okay, and it's like, as you recall, how do you find that mu sub d? When you click into that field, you get a toolbox. And one of the tabs in your toolbox is variables. You go to that and you pick the mu sub d. And then you're going to go to the inequality tab and pick the not equal to. All right. All right, so let's see what the differences are. And I said right minus left and then wrote left minus right. It doesn't matter. It really doesn't matter. And it doesn't matter because I'm looking at the difference. So it's right. Let's do it the way I said it was going to do it. Okay, so right minus left. Is that -2? Is that 3? Is that 0? Is that 1, 2, 3, -1, and -2? Now, I'm fairly decent at subtraction. If you aren't, then put this in a list. I can do subtraction in my head with positive and negative numbers. It's because I've been doing this forever. If you're not good at that, then you're going to put it in a list. So let's go over and put it in a list. So I'm going to go stat, and I'm going to go edit and see if I have any. Oh, my lists are full. So I'm going to get out of here. I'm going to go second plus, and I'm going to clear out on my list. You may not have to do this, but I'm gonna because I got all sorts of stuff in there. All right, now let's go back to stat, edit, and I'm going to put right in L1 and do it incorrectly right off the bat. 46, 47, 42. This is way faster on a calculator. It's way faster if I have a keyboard that has a 10 key on it. Doing it on this Surface Pro, it's not fast. Okay, now I'm going to go put the left eye in L2. And I'm going to do a quick check to make sure I put those all in correct before I move on.
How do you clear out the old numbers again?
So you can either go up and highlight the list name and hit the clear button and then come back down and it will be gone.
Like make L1 in dark black and press clear?
Yes, and then hit clear.
I did that.
Go back
Oh,
down.
okay.
Yeah, you got to go back down before you can see that it's cleared. All right, so I have those in correctly. So I'm going to move to L3 and I'm going to go up and highlight the L3. And I'm going to type in right minus left or L1 minus L2. So I'm going to go second 1, and you can see down at the bottom it says L1. I'm going to subtract second 2. So L3 is going to calculate, or the list L3 is going to be the calculation, the first list minus the second list. So when I hit enter, is that what I had on my paper? -2, 3, 0, 1, 2, 3, -1, -2. Okay. So now what am I going to do? I'm going to run a t-test on the differences. So I'm doing a paired t-test for the difference between two dependent means. So I'm just going to run a t-test on L3, on the differences. So I'm going to get out of here. Second, quit. I'm going to go back into my stat menu, arrow to the right to test, and I'm just going to run a t-test. And I'm going to run a t-test on data. And my mu sub 0 is I am testing to see if the mean difference is not equal to 0. So we're going to leave that 0. I have my data in L3, so I'm going to put that in there. And then I am testing not equal to, correct? So let's calculate. So my test statistic is 0.683, and my p-value is huge, 0.516. And you'll notice that it also calculates the mean of that list of differences and the standard deviation. If you need that information, it's right there. Okay, so let's go write that down. So we found our test statistic, and it is a t-score. So that is t from the dropdown. That was equal to what? 0.683. The p-value was 0.5165. So boy howdy, is that bigger than alpha? So what do? We failed to reject. Okay, so what's the conclusion? At alpha equals 0.10, no, it's not statistically significant. Okay, so that's not it. It is not statistically significant. All right, so we got 3 other choices. At alpha equals 0.10, there's sufficient evidence to conclude that the 8 volunteers completed the course faster on average with the patch. No, I don't think that is what we can conclude. At alpha equals 0.10, there's insufficient evidence. There we go. Should have grabbed onto that one at the very beginning, right? There isn't sufficient evidence to conclude that there's a difference. So there is insufficient evidence to conclude. So that's the choice. All right. Problem, whatever problem is this. What problem is this? 5. Honest, there are short problems a-coming. I like this problem for some strange reason. Does it take more time for seeds to germinate if they are near rock music that is continuously playing compared to being near classical music? The 42 seeds that were exposed to rock music took an average of 29 days to germinate. The standard deviation was 14 days. The 46 seeds that were exposed to classical music took an average of 28 days to germinate. The standard deviation for those seeds was 8 days. What can be concluded at an alpha equals 0.05 level of significance? So for this study, what are you going to be doing? Well, there's 2 samples, correct? So it's some either independent or dependent. What is this? Independent. It's independent because does one test depend on the other? Not in the least. Okay, so this is a t-test. Your choice would be a t-test for the difference between 2 independent means. Okay, so for these problems, your hypothesis test are going to be comparing the 2 means And you've got a mu1 and a mu2. And we're interested in what? What are we interested in? Does it take more times for seeds to more time? So if we let mu1 be the rock music and mu2 be the classical music, we're interested in, does it take longer, or the average time for seeds to germinate if they're listening to rock music is what? Bigger than if you're listening to classical music. So the seeds like classical music more than rock music. So this would be equals. So the null hypothesis on, I think, all of these, you just pick equals. But the alternative is greater than. All right. So what test do we run? So we got 2 samples and a t-test. So is this a 2-sample t-test? I believe so. So let's go run over to our calculators. Can you find that 2-sample t-test? So stat, arrow to the right to test. 2-sample t-test, is that number 4? And the reason, by the way, it's a t-test and not a z-test is why? Because does anywhere they give you a population standard deviation? No. They give you the 2-sample standard deviations, but they don't give you a population standard deviation. So you're going to use a t-test. So a 2-sample t-test, number 4. And I'm going to what? I'm going to put in the stats, correct? They gave me the means and the standard deviations. So I'm going to highlight stats and hit enter. Okay, and then it's just a matter of plugging in the numbers. So what do we have? So the first average for the rock music, because that is an X with a bar over the top of it. So the average of the first sample was 29 days, is what you said, 29. Out of, well, what was the standard deviation? 14 out of 42 seeds, is that correct? And then the second average for the classical music, there was 28 days on average to germinate with a standard deviation of 8. And the number was 46 seeds. And we're looking at, is mu1 greater than mu2? So we're going to pick greater than. Does it take longer for the rock music seeds compared to the classical music seeds? Okay, I'm not going to pool my variances, and then I'm going to hit calculate. So my test statistic is T. T is 0.406. The p-value is 0.3429, the 4 decimal places. So let's go type that in. So the test statistic is a t-score. So pick t from the drop down, and it's equal to 0.406. And the p-value was, again, I apologize, one of them you would hope you would reject, but you can't reject it with a p-value that high, can you? The p-value is greater than alpha. So again, we fail to reject. Okay. Are the results statistically significant? They are not. So I got 2 with insignificant in them. So it's one of those. Which one is it? The results are statistically insignificant, alpha equals 0.05. There's insufficient evidence to conclude. So this, not this one. Because if it's insignificant, so there's a statistically significant, no. Does it have to be this one? It has to be. And it also says is more than, which is what we tested. Is the time for the rock music seeds more than the time for the classical music seeds. Okay, what's the p-value? The p-value was 0.3429. So P is 34.29%. If the population, I think it's just the first one, isn't it? It's got to be the first one because it's the only one that contains the word population. Oh, this one. Where is it? There it is. I'm sorry, I'm scrolling all over the place. It's got to be the first one because it's the only one that contains population proportion. Population mean, excuse me. So it's got to be that one. Not to give you a hint, but I'm giving you a hint. All right, interpret the level of significance. So the level of significance, alpha was what? 0.05, 5%. That is the probability of a type 1 error. A type 1 error would be that you reject the null when it's true. So you would accept the alternative. If you reject the null, you're accepting the fact that the classical music seeds germinate in less time than the rock music seeds. So what have we got here? Is it this one? Because you would assume that it's more than when it isn't. So you would make that error. All right. Are we having fun yet? Question 6. Questions. It won't take you that long. A retailer wants to see if a red sales sign brings in more revenue than the same sales sign in blue. The data below shows the revenue in thousands of dollars that was achieved for various days when the retailer decided to put the red sales sign up and days when the retailer decided to put the blue sales sign up. So we have the sales data for red signs and blue signs. Assume that both populations follow a normal distribution. What can be concluded at an alpha of 0.01 level of significance, I don't know why it repeats the level of significance, but it did. So what test are we going to use? You got two sets of data. So it's either what? Dependent or independent? Which one is it?
I'd say it's dependent because it's the same store, it's just a different sign.
It's independent. And the reason it's independent is because you're testing two things that are not related to each other at all. They're just different color signs. So you're not looking at a before after kind of thing of the same person. You're not covering the same person's two different eyes. So it is dependent. So that big old long choice, what is it? A t-test for the difference. At least you don't have to write all this out. You just have to pick it from the drop down. Between two independent population means. And so we're going to do what? A 2-sample t-test. Okay, so what are we looking at? Again, on these independent tests, you're going to be testing a mu1 compared to a mu2. And we're just testing to see, what are we testing? If red is bigger than blue? More, red's more. So red is bigger than blue. Okay, so I need to go put this data in my calculator. And I'm going to avoid deleting anything from my list until I have to. So I'm going to put this data in L4 and L5 because I have 6 lists. I might as well use them. And I do have to put it in a list. I have to let my calculator calculate the averages and stuff for me. So I'm going to go to my list. And I'm going to put red in L4 and blue in L5. No, we aren't doing red minus blue. We're checking to see if red is bigger than blue. So we're not looking at differences in terms of two dependent means. We're just saying, okay, we're going to calculate this mean, we're going to calculate this mean, and see if they're significantly different from each other. Okay, so what do we got? 2.5? So I don't calculate differences for independent populations. Okay. Okay, so I have my data in. I'm going to do a real quick check to make sure I have everything in there correctly, because gosh, that's the only defense I have between getting the answer right and wrong. Okay, so I'm good to go. So I'm going to exit out of my lists. So I'm going to do a second quit. And I'm going to go back into stat. And I'm going to go over to tests. And I'm running what? A 2-sample t-test. 2 independent samples running a t-test on it. So is that number 4? And you'll notice when I go over to data and I hit enter to highlight that, it asks me, where'd you put your data? And it's going to calculate the means for me, the standard deviations for me. It's going to calculate all that. So I put my data in what? L4 and L5, second 4, second 5. And I'm interested in what is red bigger than blue. So I do want greater than. I'm not going to pool the variances, and I'm going to calculate. Okay, so my t statistic is 1.187. The p-value is 0.127, 1271. And if you remember from when we covered the 2-sample t-test, the degrees of freedom, remember how awful that calculation was? A big old long, ugly calculation. It calculates it for you. So if you needed it, there it is. And then you see the means of the 2 groups. So the mean for the red sign is 2.667, and the mean for the blue sign is 2.089, and the 2 standard deviations. Okay, so let's go back and let's input that into our test. So the test statistic we found is a t statistic, correct? And it was equal to 1.187. And that the p-value is what, 0.1271? And that is bigger than alpha. So again, what do? Fail to reject. I don't guarantee that on the review you do for your homework that it will all be fail to reject. It just happened to be on this one. All right, so what's the final conclusion? If we fail to reject the null hypothesis, the sample data is not significant. So it's not statistically, no. So it's one of the last 2. Test results are statistically insignificant, so nope, it's not that one. It's got to be this one, doesn't it? The results are statistically insignificant at alpha equals 0.01, so there is insufficient evidence to conclude that the population mean revenue on days with a red sales sign is more than the population mean revenue on days with a blue sales sign. So what was the p-value? Or 12.71%. Oh, it's got to be this one. I gave it away earlier, didn't I? Got to be that one. Why is it got to be that one? Population. Level of significance. The level of significance was 1%. Is that correct? And again, what is that? That is a type 1 error. That's the probability of a type 1 error. And a type 1 error is that you reject the null when it's actually true. So you accept that the red sign's revenue is more than the blue sign when it actually isn't. So which one says that? The last one? More than. Yep, that's the one. And then they ask you something down here, a 99% confidence interval for the difference in mean revenues in red versus blue sign. So they want you to create a confidence interval for this data. So what are you going to use? You're going to use a 2 sample t interval. So you're going to find an interval for the difference in these means. So in the middle, you pick mu1 minus mu2. And then go run the test for the confidence interval. So let's go do that. And it will remember that you put data in when you go over there and run it. Let me show you what I mean. If my computer will wake up here. There we go. Okay, so when I go to my calculator and I go stat test, and I find the 2 sample t interval, and we don't use 9 because that's a z interval. And we're running a t test, not a z test, because we don't know the standard deviation. So it's going to be what? 0, 10, 2 sample t interval. And it will remember that I ran the previous test on data, and my data was an L4 and L5. It remembers all that. Isn't that convenient? Okay, what level of confidence do we need? 99%. So what's my confidence interval? From negative 0.8607 to 2.0163. So I'm 99% confident that the true difference in the means is somewhere between negative 0.8607 and 2.10163. So let's go type those in the fields. So this is going to be how many decimal places? They don't tell me. So I'm going to do 4. 0.8607 and what? 2.0163. You know, if they don't tell you how many decimal places to round off, 4 is a good place to do that, or a good number. All right. Question 7. Are Republicans more likely than Democrats to display the American flag in front of their residence on the 4th of July? 412 of the 623 Republicans surveyed display the flag on the 4th of July, and 398 of the 644 Democrats surveyed display the flag on the 4th of July. What can be concluded at an alpha equals 0.01 level of significance If the calculator asks, be sure to use the not pooled data option. So what are we using? So we got two populations. They give me averages? They give me proportions? So is this a z-test? Because it's binomial? We're using the normal approximation to the binomial, so it's a z-test. A z-test for the what? The difference of two population proportions? And we'll cooperate. So what are my null and alternative hypotheses going to be? Well, I'm comparing two proportions, so it's going to be a P1 and a P2. Correct? And then what are Republicans more likely? So is that proportion greater than? Is that what we would test? That the Republicans, if we let them be P1 and we let the Democrats be P2, that P1 is bigger than P2? Okay, and it's going to be a Z statistic, correct? Because we're running a Z test for two population proportions. So let's go run it. I should have written this down. I didn't. Let me go write it down. So we're going to be running a two proportion Z test. All right. So we're going to go stat, arrow to the right to test, to the right, Lisa, there you go. And a two proportion Z test, is that number 6? And then you just plug in the numbers. So what did we have? For the Republicans, did we have 412 out of 623? So 412 out of 623, did they display their flag on the 4th of July? And how about the Democrats? Was it 398 out of 644? And we're interested in greater than, is that correct? Is the Republicans bigger than the Democrats? So our test statistic Z is 1.605 to 3 decimal places, and the p-value is 0.0543 to 4 decimal places.
P-value? Oh, sorry.
Did you get it? Okay. Thank you for those of you who answer. I appreciate that. Okay, 1.605 for the Z score, and the p-value was 0.05. And what was alpha? Still bigger than alpha, isn't it?
Yeah.
0.05 is bigger than 0.01, correct? So again, the p-value is greater than alpha. And what do we do if it's bigger? Do we fail to reject? I suppose that's a nice fail to reject. So the conclusion is that it doesn't matter what party you belong to, you display your American flag, I suppose. All right, so what do we got here? So since we failed to reject the null hypothesis, our samples are not statistically significant. They're statistically insignificant. So that one says statistically insignificant. So it's not that one. That one says statistically insignificant. That one does not. So it's one of those two, correct? greater, it's this one, is it not? Because what you're rejecting is that Republicans display the American flag more than Democrats on the 4th of July. Okay, part G. Do each of these problems have to have 900 parts? Yes, they do. Is it? It's a little bit different. Which one is it? Well, it's not the two short ones. That would be too easy. It is the last one. Because it's not sample proportion. So if the percent of all Republicans who display the American flag in front of their residence on the 4th of July is the same as the percent of all Democrats who display the flag in front of their residence on the 4th of July, and if another blah, 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 blah. Okay, how about H? We're interpreting alpha. Alpha is 0.01, 1%. That is, again, a type 1 error. So this is rejecting the null when it's true. So this is accepting the fact that Republicans display the flag more on 4th of July. So this is the survey. Republicans display. It's the last one. You are correct. Because the key word is greater. All right, are you ready for some easy ones? Now, I don't guarantee yours is going to be true or false like mine is, but we got a bunch of true and false. Now, the nice thing about true and false is you kind of breathe from all these calculations. The bad thing about true or false is it's binomial, isn't it? You're either right or you're wrong. 95% confidence interval, the means was computed with a sample size of 100 to be 10 to 14. So the confidence interval starts at 10 and ends at 14. Then the error is plus or minus 2. What's the middle of that interval? 12. So is the error plus or minus 2? So is the middle 2? Middle is 12, is what you told me. So is 10, 12 minus 2 is 14. 12 plus 2. So is the answer true? Okay, how about the next one? If the sample size is increased and the standard deviation and confidence level stay the same, then the margin of error would also be increased. Do you remember what that formula vaguely looks like for sample size and margin of error, error bound to the mean? Do you kind of sort of remember what that looks like? It's on your formula sheet. So is it Z times, do I remember what it looks like? But I do know that N is in the denominator, right? So if I increase the sample size, does that increase the error bound to the mean? What happens if you increase the size of a denominator of a fraction? Does the fraction get smaller? So is that true? Nope. If you increase the sample size, it does what? It decreases the margin of error. It decreases the error bound. All right. If N is 29, X bar is 42, and S is 16, construct a confidence interval at a 98% confidence level. Oh, that's easy enough. So they give me an X bar and an S. So is this a T interval? Why is it a T interval? Yep. Because they do not give me sigma. Sigma is unknown. So, and they give me an X bar. They don't give me a mu. So since they give me sample statistics, they give me a mean of a sample and a standard deviation of a sample, we would use a t-interval. So let's go find the t-interval. So stat, arrow to the right to tests. Do you see a t-interval? Is that number 8? So then we just input the stats, correct? They give me stats. I don't have data. So the mean was what? 42? The standard deviation was 16. And we sampled what? 29? And the confidence level is 0.98. So 34.67 to 49.33. So go put those two values in the fields. There we go. 34.67 to 49.33. Okay, problem 11. Your breather was short. There's more simple questions toward the end. You're interested in finding a 95% confidence interval for the average commute that non-residential students have to their college. The data below show the number of commute miles for 13 randomly selected non-residential college students. Round answers to 3 decimal places where possible. So to compute the confidence interval, we're going to use what kind of distribution, a T or a Z? You're given data for 13 people. Would you use a Z? Would you use a T? With 95% confidence. Okay, by the way, on part C, if you don't put 95 there and 5 there, I'm going to yell at you. Because it's saying about 95% of the confidence intervals will contain the true population. That is what a confidence level is. It tells you that if you do another sampling, 95% of the time, the true population mean is going to somewhere be in between those two numbers. Okay, so we're just going to go put this data in our calculator. You could calculate the average and standard deviation and do it that way, but I'm going to let the calculator do it. So I'm just going to put this data in list. I got one list left, right? L6. So I'm going to put it there. And then I'll eventually have to start clearing out lists. So we're going to run out. So I'm going to go to L6 and I'm going to put these 13 commute distances in there. All right, I'm going to do a quick check. Okay, so I'm going to exit out of my list, second quit, and then I'm going to go to stat and tests, and I'm going to be finding what? A T interval? Is that number 8? But this time I'm going to be calculating this interval based on the data that I put in. So I'm going to go to the input. I'm going to highlight data and hit enter. And I put my data in L6. So I'm going to tell my calculator L6. And what confidence level are we using? 99? No, wrong problem. 95. So change that to 0.95. So from 11.74 0.54 to 17.477. So I'm 95% confident that the true population mean is somewhere between 11.754 miles and 17.477 miles for these non-residential students. Okay, so let's go input that into, oops, hit the wrong button. Input that into our problem. So 11.754 and 17.477. All right. Question 12. Do we have time? Probably. This will be the last problem. And again, we're finding a confidence interval, 99 and 1, correct? Okay, a news group is interested in constructing a 99% confidence interval for the difference in the proportions of Texans and New Yorkers who favor a new green initiative. Of the 575 randomly selected Texans surveyed, 419 were in favor of the initiative. And of the 548 randomly selected New Yorkers, 461 were in favor of the initiative. So they don't give me means, they give me proportions, correct? And they give me proportions from two different groups. And I'm calculating an interval. So is this a 2 proportion Z interval? Again, it's a Z, and all the proportions are going to be Z somethings because we're looking at the normal approximation to the binomial. Okay, so we're going to go to our calculator. We're going to go stat over to test, and where's my 2 proportion Z interval? Is it B, 2 proportion Z interval? And we hit enter, and then it just tells us to put in the data, doesn't it? So what did we have? 419 out of 575 Texans, 419 out of 575, is that right? And then what about the New Yorkers? 419 out of 548?
I think it's 460.
Yeah, 460.
530.
Yeah, 548 is.
Yep, you're right. You are correct. You are correct. See, I just made that mistake to see if you were awake, and you are. Proud of you. As she says with a big smirk on her face. So negative 0.175 to negative 0.0501. So we are 99% confidence that the true population proportion, the difference in the proportions, it is a difference. That's why you can get negatives, is somewhere between negative 0.175 and negative 0.501. So I'm gonna type that in real quick. That's not the window I wanted. That's the window I wanted. So what did we get? Negative 0.175 and negative 0.0501. Are there any questions? That is correct.